Have you ever wondered about the origins of the universe, how everything came to be? Let's take a moment to ponder the vast expanse of the cosmos, a space so vast and complex it's almost impossible to comprehend. In the grand scheme of the universe, we are but a speck of dust, living on a tiny planet in a galaxy amongst billions. Yet our curiosity leads us to seek answers, to understand the beginning of it all. The Big Bang Theory, first proposed by Georges Lemaitre in the year 1927, offers a compelling explanation. It describes the universe's expansion from a high-density and high-temperature state. Today we unravel the mystery of the Big Bang Theory. In the beginning, there was nothing but a singularity. Picture, if you will, a point so small it's impossible to measure, yet so dense and hot it's hard to fathom. This is the singularity, the starting point of everything we know as the universe. It's like the ultimate magic trick, where from nothingness everything sprouted. The singularity wasn't a thing or a place, it was a state of infinite density and unimaginable heat. It was from this tiny, intense point that the universe began to expand. According to the Big Bang Theory, this process of expansion started around 13.8 billion years ago. The singularity, under extreme pressure, began to expand, pushing outwards, creating space and time as we understand it. This initial state of the universe, the singularity, is the point from which all galaxies, stars, planets, and life itself originated. It's the genesis point, the foundation of everything, the very cradle of existence. So next time you gaze upon the night sky, remember that everything you see, everything you know, and everything you are started from that one tiny, infinitely dense and incredibly hot point. From this singularity, the universe as we know it began. The Big Bang was not an explosion, but an expansion. This is a common misunderstanding that we often come across. In this scenario, the term Big Bang is a bit of a misnomer. Instead of a colossal explosion in the conventional sense, it was an unfathomable expansion from an intensely hot and dense state. Now let's imagine this scene. Everything that exists, all matter and energy, compressed into an infinitesimally small point. Suddenly this point begins to expand. As it expands, it cools down. This cooling down process is no less than a cosmic miracle. It's during this stage that the universe as we know it started to take shape. Subatomic particles, the smallest building blocks of matter, began to form as the universe cooled. These particles came together to form atoms, primarily hydrogen and helium. Over time, these atoms clumped together under the influence of gravity, forming stars and galaxies. This process of formation and organization didn't happen overnight. It took billions of years for galaxies, stars, and eventually planets to form. But how do we know that this is how it happened? One of the key pieces of evidence supporting the Big Bang Theory lies in the movement of galaxies. When we observe distant galaxies, we find that they are moving away from us. And the farther away the galaxy, the faster it's moving. This is consistent with the idea of an expanding universe, a universe that started from a single point and has been expanding ever since. The universe continues to expand even today, billions of years later. So the next time when you gaze up at the night sky, remember that you're not just looking at stars. You're witnessing the ongoing expansion of the universe, a process that started with the Big Bang billions of years ago. So, how do we know all of this happened, you might be wondering? Well, the evidence lies in the cosmic microwave background radiation and the abundance of light elements. You see, the cosmic microwave background radiation is a relic from the early universe, an echo of the Big Bang. This radiation was discovered in 1964 and has been a major piece of evidence for the Big Bang Theory ever since. Let's not forget the abundance of light elements. Elements such as hydrogen, helium, and lithium were formed in the hot, dense early universe. The quantities of these elements we observe today align remarkably well with the predictions made by the Big Bang Theory. Scientific observations and measurements, as you can see, play a crucial role in supporting the Big Bang Theory. They're like puzzle pieces, each adding to our understanding of the universe's beginnings. It's a fascinating journey, piecing together the story of our universe, and it's far from over. These pieces of evidence paint a vivid picture of our universe's birth. Yet the Big Bang Theory leaves some questions unanswered. As comprehensive as it may be, there are still gaps in our understanding. For instance, why is there an unequal abundance of matter and antimatter? This asymmetry is a puzzle that scientists are still trying to piece together. Then there's the enigma of dark matter and dark energy. These unseen forces are believed to be the scaffolding of our universe and the drivers of its accelerated expansion, yet their nature remains elusive. We also grapple with the limitations of our current theories. General relativity, for example, has been a cornerstone in our comprehension of the cosmos, but it begins to falter when we extrapolate back to the universe's infancy, to the singularity from which everything sprung. These mysteries might seem daunting, but they are also what makes the study of the universe so exciting. Each unanswered question is a door to new knowledge, a challenge to the ingenuity of our scientific community. As we continue to explore, we get closer to understanding the grand design of our universe.